I want to talk about null. I can't go into too much more depth about what I want to say about null because that might give the game away, so why don't I jump right into the premise. Here, we have some randomly generated data. And this is not particularly interesting randomly generated data, it's just some names and some values. So you can imagine that we've collected some information, some signals, there's a tag on each signal and there's some values. And when we have names and values, it's very likely that we might want to do some kind of analytics. For example, we might want to do a grouping on these values. So here's a query that takes all of the names of the values and it just groups them by the first two letters. All the BCs, all the 3-3s, all the F9s together. And they perform a small summary statistic on this. And the summary statistic that is performed is, let's just compute the average. Now, there's a small detail to how they perform this summary statistic. The average was computed not using the built-in AVG function, but instead by computing the sum and the count and dividing those. And this may have been done because maybe the built-in AVG function wasn't sufficient for their purposes. Maybe they needed a summary statistic that wasn't available in SQL. For example, a kurtosis, a skew, some higher order moment, or maybe there's a slight modification. Maybe they want to do the absolute value of the sum and then the count or something like that. And so breaking this up may seem like a fair thing to do. Can you spot what makes this query bad? Now, I'll give you a hint, but it's going to be a very, very, very short hint because otherwise I would give the game away. Think about nulls. Is there something that could be wrong about this query if the dataset included nulls? Be sure to chime in on Discord or in the Q&A widget if you think you've spotted what's wrong with this query. I'll give you just one more moment, and then we'll talk about the answer. If you said there is a subtlety to how count works, and that count on a column versus count star have a slightly different behavior in the presence of nulls, you are absolutely correct. In fact, this query will in some cases misrepresent what the average value is because this will perform the count of the total number of rows in the group, not necessarily the total number of rows in the group that happen to have a non-none value. And so there is a subtle difference where if we had null values, these two options might differ. Now, as is always the case, the actual answer itself is generally fairly straightforward. There may be no more than a couple character or one line change that we need to make to this query. But what's a lot more interesting is to think about the reasoning behind why null exists and what this tells us about our use of SQL and how we construct queries. So as a very quick refresher, remember, SQL implements what you might call a multi-value, tri-value logic. And that logic involves things like true values, false values, or general numeric values, textual values, but there's always this optionality. The value can potentially be null if the table has allowed null values. Null is a very special value. It is akin to the floating point nan in terms of its behavior. Specifically, null is not equal to anything, including itself. You can see some kind of saturating behavior here. When you perform an operation where one of the two sides is null and you perform an equals, the result here isn't false. The result here isn't true. The result here is, I don't know. Because you can think that that null kind of represents a, I don't know, or doesn't quite fit here, a not applicable or not available. And so null is not equal to null. Null equal to null is null. Null is not equal to null. Null not equal to null is null. Null is not greater than null. The result is null. Null is not less than null. Now, let's think about what happens when we have a table that might include null values. And this is the case where we haven't either marked a nullability constraint on one of the columns, such and such column not null, or where maybe there is a meaningful use of null here, but we haven't taken into account how that might affect our queries. Do note that the situation with null is not intractable. If you were to look at a query like this, using the any or the all syntax, well, the any or the all syntax means, are any of these rows equal to, greater than, less than, whatever the case may be for the comparison operator we're using, some particular value. So this query should say, return one row if any of these values, true, false, or null, are equivalent to true. And at least one of them is equal to true. That happens to be the true value itself. And so this does correctly return one row. One thing that you might not know is your select statement does not actually have to have any columns selected. We'll see whether this succeeded or failed just in terms of how many rows it returns. But these are rows of zero-element tuples. Now, that seems very reasonable. One of them was true, and so this worked exactly as we expect. If we use an all here, and we put in two true values and a null value, well, you can think not all of them were true, and so this works exactly as we expect. When we think about null, we shouldn't think about some uncontrollable, avoidable, if we just set a non-null constraint on everything type of problem. Null has its own rules associated with it. It's something that we do need to be aware of, and there is no shortcut to avoiding this problem. In the case of the query that we saw, note that if you perform a sum on a column, and that column contains null values, you get the opposite of the pandas behavior. In pandas, if you have a nan value, that nan saturates on a sum, and the entire result turns into a nan. Whereas in SQL, the null is basically coalesced. It's treated as though it is a zero value. So you can see here that I can sum on a null. And this is something we should be aware of. When you perform operations like count, there's a difference between saying count column and count star. Count column counts the number of non-null values. So if we were to use this count as part of a summary statistic, well, the count may not actually represent the total number of columns we've seen. And if we were doing some kind of weighted statistic, you can imagine where if one of these counts are wrong, it could lead to the statistic being incorrect. This is different than count star, which just counts the total number of rows, irrespective of whether any of these rows happen to be null or not. And it's not the case that in the previous mistake, you might strictly want to choose either count column name or count star. It may be the case that you need to really think about what does this null mean. I cannot stress this enough. You cannot avoid what null means or what null represents or what null it does for you in your data sets. And this speaks very deeply to what SQL is actually for. Let me give you a scenario. Let's say you are collecting some kind of important data, say medical data. And as a consequence of that medical data, maybe you need to collect some information about the patients. For example, their name, the city they live in, and their state. It may be very important that you collect the state information because, for example, for public healthcare billing purposes, you may need to know which state to bill to, or there may be some various regulatory requirements around reporting if you happen to have a patient from a particular state. And so you say, I am really worried that I'm going to write queries, and as a consequence of how these queries do joins or equals, that null is going to lead to weird results that I can't understand, so I'm just going to put a non-null on the state column, and everything will be fine. But here's what's going to happen. You're going to end up with nulls in your data set if null is a meaningful thing for the data that you're representing. And if you think about it, is it meaningful for a patient to not have a state, for it to be unknown or not applicable? Absolutely. For example, what if the patient is not able to report at time of being serviced what their state is? What their state of residence is, I should say. What if, for example, this happens to be a foreign visitor who comes from a country like our neighbors to the north in Canada, where they don't have states, they have provinces. So there really isn't an applicable thing that they can fill in. Well, consider if the data that you're collecting is important. It's probably because the thing that it's supporting is also important. If you have a patient waiting in the waiting room, and you have some sort of medical EMR system, and in that medical EMR system, there's a field for filling in the state of residence, the state that you live in, and you have someone from Canada who needs medical attention, and you say, just fill in your details and then we'll see you back. Maybe not urgently, but within the next hour or so, we should definitely see them. What's going to happen is, if your database says, well, we don't want nulls because it's going to lead to analytical oddities, or it's going to lead to us having to worry about them when we do analysis, you're going to have cases where you want to collect data, and as a consequence of the web form erroring out if you don't fill in a field, therefore making it required, you're going to either, one, not be able to collect any data from that patient because they'll go to that field and say, I don't know what to put, in which case you threw away all the useful data you could have collected, or even worse, the staff at that medical clinic is going to say, oh, yeah, if it's not applicable, fill in this value. Fill in NA. What is NA? Is that an abbreviation for Nevada? No, Nevada is NV. What is NA? Well, anytime we have these systems that are so constrained about how they collect data, where the analytical constraints are tied to the data ingestion constraints, it is almost unavoidable that people, as regular human beings, will find workarounds. If this were a paper form, you just scribble through it, or you just would leave it blank. But in a computational form where there's some overseer who you can't just go and say, hey, relax this constraint for this one row of data, people are going to find ways around it. So either they'll encode the idea of not applicable or missing through other means, NA, in which case your queries will become enormously complicated, having to not just check for null with a select something is null, but instead a select is NA, N period, A period, NA all lowercase, or you're going to have to throw away all of this data. What does this mean for us? Well, when we think about constraints, when we're modeling in SQL, we shouldn't avoid using constraints. This is the wrong answer that a lot of large companies fall into. They say, you know what, don't use any of the features of SQL, don't use constraints at all, because it leads to these kind of data collection problems. But then at the same time, there are cases where it doesn't make sense for some of these fields to be null. There may be a case where, if the patient doesn't have some unique identifying mark on or some unique identifier for them, you can't really see them. Or, for example, the time when you saw the patient, what would it mean for that to be null? That has to be a piece of information that exists. And the non-presence of that information is itself wrong, and that's something you want to capture. Well, the circumstances under which you do or do not want to capture, or accept or do not want to accept this data, are going to vary. The real answer for how we work with SQL and how we work with constraints, like a null constraint, and how we approach null in the first place is this. Remember, SQL is largely a pretty strong but kind of hairy in some legacy ways tool for analysis. It's not really a tool for data collection or data ingestion. My suggestion would be, if you happen to have any circumstance where you don't have an absolutely definitive sense that the data must look this way, the age ranges must be from this to this, and there's no possible physical way it couldn't be the case. This information must exist. If it doesn't exist, we must be on Mars. Or this information must exist because, humanity is never going to make it to Mars, whatever the case may be. Then you can model those in your SQL database. Otherwise, what you should actually do is be very, very light-handed in your ingestion. This is actually a pretty decent place in data ingestion for the use of things like NoSQL databases. Allow any data to be ingested and put very minimal constraints based off of things which are otherwise physically impossible to be missing. And then, once you've collected that data, have a parallel database that does the analytical uses, which goes through the data, identifies valid records, and then extracts those to something that's analytically clean, so you don't have to do all of this. Well, is it n space a, n/a? Because that will happen. SQL is a good tail-end analytical tool. Not end-to-end, from data ingestion all the way to analysis, but from having collected and probably even cleaned data, from that clean data step to the analytical stuff. And as long as you keep your use of SQL in that domain, from clean data to analyze data, you'll actually find that it is a very reasonable tool to use, and all of these fantastic features work extraordinarily well to make your life easier.